space is silent. In the vacuum between the stars, there is no air to carry a sound, no one to hear you, and nothing to hear. That is what we are taught, and it is almost true. But 240 million light years away, something is singing. One note, the same note, held for longer than there has been complex life on Earth. It is the deepest sound ever detected in the universe. And thanks to NASA, in a few minutes, you are going to hear it. To understand how a sound can exist in space, you first have to give up the idea that space is empty. This is the Perseus cluster, thousands of galaxies, bound together by gravity, one of the most massive structures we know of. And the galaxies are not the main event. The space between them is flooded with a vast cloud of gas. Thin, but scorchingly hot, millions of degrees, glowing in X-rays. That gas is billions of times thinner than the air you are breathing right now. But it stretches across millions of light years. And it is just dense enough to do something the empty vacuum cannot. It can carry a wave. Because that is all a sound really is, a pressure wave moving through something. And the Perseus cluster has an entire ocean of that something. We only know the gas is there because it glows in X-rays, invisible to our eyes, but not to a telescope like NASA's Chandra, flying high above the atmosphere. And when you weigh it all, something strange emerges. There is more mass in that thin, scorching gas than in every star, in every galaxy of the cluster combined. The galaxies are just the bright islands, scattered across a far greater, hidden sea. At the center of that cluster sits a supermassive black hole. A black hole is not really a cosmic vacuum cleaner. As matter spirals toward it, it hurls enormous jets of energy back out, and those jets blow colossal bubbles into the surrounding gas. As the bubbles swell and rise, they push on the gas around them. They send out pressure waves, sound waves, rolling outward through the cluster for hundreds of thousands of light years, like ripples from a stone dropped into a pond. In 2003, the Chandra X-ray telescope photographed those ripples directly. Faint, concentric rings in the hot gas. A sound wave, frozen into an image. It was a team led by the astronomer Andrew Fabian in Cambridge, who first understood what they were seeing. Not random noise in the gas, but the wake of a sound, spreading out from the black hole across the entire cluster. And when astronomers measured the pitch of that wave, they found a single note. A B-flat, but a B-flat 57 octaves below the middle of a piano. So low that just one of its waves takes nearly 10 million years to pass by. 1,000,000 billion times deeper than anything a human ear can hear. And the black hole has been holding that one note for something like 2.5 billion years. For 60 years, that sound was something we could only see and calculate, never actually hear. Then, in 2022, a team at NASA did something simple and astonishing. They took the real data, the actual sound waves rippling through the Perseus cluster, and they raised the pitch. Not a little. They shifted it up by 57 octaves, scaling the frequency up by hundreds of quadrillions, until at last it crossed into the range of human hearing. Nothing was invented. Nothing was added. This is the real thing. A black hole, 240 million light years away, sped up just enough for your ears. So listen. That low, aching moan is the pressure of a black hole, written into a cloud of gas the size of a galaxy cluster. And it is not just a curiosity. Those same sound waves carry staggering energy, something like the equivalent of 100 million supernovae, pumped into the cluster over hundreds of millions of years. That heat keeps the gas from cooling and collapsing into new stars, which means the black hole song is shaping the cluster itself. It is helping to decide, note by note, how many stars can ever be born there. For years, this was a real puzzle. By all rights, that enormous cloud of gas should cool, fall inward, and collapse into a blaze of new stars. But it doesn't. Something keeps reheating it, holding it back. And the best answer we have is the black hole. Its jets, its bubbles, and these very sound waves, gently keeping an ocean of gas warm across millions of years. A single object, at the center, acting like a thermostat for an entire cluster of galaxies. A sound too low to hear, quietly writing the future of thousands of worlds. It is not the only black hole we have listened to. The one at the heart of the galaxy M87, the first black hole ever photographed, has a sound of its own, drawn a different way by translating the light of the image into tone. And NASA didn't turn these black holes into sound just for the spectacle. Turning data into sound lets us notice things the eye can miss, and it opens the universe to people who could never see these images at all, including astronomers who are blind or have low vision. It is, in a quiet way, a new sense pointed at the sky. But the Perseus note is the one that stays with you, because it was already there, long before anyone built a telescope, long before there were ears on Earth to miss it. That single, impossibly deep note was already rolling out through the dark. We tend to picture space as cold and empty, and above all, silent. And it is mostly silent, but not entirely. Here and there, in the great clouds between the galaxies, something is humming, a sound so vast and so slow that we very nearly missed it. For all our telescopes and instruments, the universe had been playing this one note the entire time. We were simply never quiet enough to notice. We just had to learn how to listen.